find the complete integral of this equation. And for that, first we have to take f to be equal to, I'm taking this one to the other side, and this is p plus q into px plus qy minus 1. And this is p plus q into px plus qy minus 1. And now we are going to use the Charpit's auxiliary equations for this. So first is dx divided by fp. So derivating f with respect to p, what we are getting? First function derivative of second. So it is x plus second function derivative of first. So it is 1 with respect to p, right? So we are getting p plus q into x plus px plus qy. So this is further equal to x multiplied with p, we get px, and here also we have px, so this is 2px plus then xq plus qy. We can also take q common from this, so this is 2px plus q into x plus y. So writing here 2px plus q into y plus x equals to, now derivating f with respect to q, dy divided by derivating f with respect to q. So when derivating f with respect to q, again we get by similarity, this is 2qy plus p into y plus x. Then dz divided by p multiplied with fp. So this is already your fp. So we just need to multiply p here. So this is 2p square x plus pqy plus pqx plus q multiplied with fq. So this is 2q square y plus pqy plus pqx. So we can take 2 common from this, and also this is twice of pqx and twice of pqy. So let's take 2 all over common from these terms. Then dp divided by negative of fx, derivating f with respect to x, what we get? So when derivating f with respect to x, what we get? We get p square and plus qp. That's it. Similarly, when derivating f with respect to y, we get q square plus pq. So writing here fx to be p square plus, alright, I'm writing pq. For qp I write pq. And what is p multiplied with fz? Here there is no z, right? There is no z, so fz is 0. So this is equal to dq divided by negative of q square plus pq. Fz is 0. Now we need to choose those ratios for which either we get the value of p or q, or we get the relation between p and q, right? So what is easier to choose? I think this is easier to solve these two ratios, right? So let's consider dp divided by, let me take p common from here, it is p into p plus q with negative sign equals to dq divided by, let's take q common from this, so this is negative of q into q plus p, cancelling the negative signs, and also p plus q. So we have dp divided by p is equal to dq divided by q, and when integrating these two, we get this to be log of p equal to log of q plus log of the constant a. Log of p equals to log of q into a. And from here we get p is equal to q into a. So we are getting the relationship between p and q. Now what is given equation? This is our given equation. So we can now put the value of this p into this equation so that we can get p and q separately. So we have the given equation to be p plus q into px plus qy equals to 1. And from here we get p equal to qa. Let's put p equal to qa over here. So we have q into a plus 1 into ax plus y into, okay, let's take q outside, equals to 1. So we have q square to be equal to 1 divided by a plus 1 into ax plus y, or q is equal to a plus 1 into ax plus y. Now next, to get the value of p, just put this value of q in this equation. So p is equal to q into a. So I need to just multiply a with the value of q, right? Okay, third step is to use dz equal to p dx plus q dy. To get the value of complete integral, we need to find what is z. So dz is equal to, okay, writing p, that is a divided by square root of a plus 1 into ax plus y dx plus q into, okay, this is 1 divided by square root of a plus 1 into ax plus y dy. Square root of a plus 1 is constant, and we can take this to the other side. Square root of a plus 1 dz equal to a divided by square root of ax plus y dx plus 1 divided by square root of ax plus y dy. So further, this is equal to square root of a plus 1 dz is equal to a dx plus dy divided by square root of ax plus y. It's common in the denominator. Can I write this numerator to be the derivative of ax plus y? Can I write like this? Yes. When you open this, you will be getting back this a dx plus dy. So in the next term, I'm writing derivative of ax plus y divided by square root of ax plus y, and here square root of a plus 1 dz. And now we can easily integrate both the sides. This is constant, so this is square root of a plus 1 z equals to, integrating this with respect to ax plus y, what we get. So this is ax plus y minus 1/2 plus 1 divided by minus 1/2 plus 1 plus the constant b, where b is a constant. So further, this can be written as, it is ax plus y 1/2 divided by, this is 1/2, or it can be written as twice of square root of ax plus y plus b, and here square root of a plus 1z. So this is the required solution, which is the required complete integral of the given equation. Okay, a very important thing to note here, because a and b are constants, right? If I give the value a to be 0 and b to be 0, what I get from here? I get z is equal to 2 square root y, yes, or z square is equal to 4y, which becomes the particular solution of the given equation. Alright, thank you, stay blessed.